Hello students, welcome to digital classes. In this class, we are going to discuss an important topic, circles. By the end of this session, you will learn definition of the circle and related terms, arcs and segments of the circle, angle subtended by a chord. Students, observe the figures. This is a earth and this is Ashoka Chakra and this is a CD and these are all different kinds. So, what is the common thing in these students? So, these are all circular objects. So, all these are circular objects. Now, let us see this. This is a bangle. With the bangle, circle is drawn. So, what is this students? Outline along the edges of a bangle form a circle. So, previously we have seen circular objects and this is a circle. Now, tell me what is the difference between the circular objects and the circle? All the circular objects we have observed above have thickness and are three-dimensional objects. That means, all the circular objects we are having are three-dimensional objects, and in the same way, whereas a circle is a two-dimensional figure with no thickness. Let us take another example of a circle. So, you might have seen the oil press called oil mill. So, in this is the oil press and one bullock will rotate like this so that oil will come out. So, this is called Spanish wheel, or in Telugu we call it as Ganuga. So, in this what happens is a line along the boundary made by the bullock is a circle. So, bullock will rotate like this while making a circle. So, the bullock makes a circle. The oil press is attached to the ground at a fixed point which is the center of the circle. So, this is the oil press which we call it as center of the circle in this, and the length of the fulcrum with reference to the circle is radius of the circle. So, in this Ganuga, the line along the boundary made by the bullock is a circle and the oil press is called center and the fulcrum is a radius. Now, students, make any 5 points A, B, C, D, E on the circle. So, this is the circle, the points are A, B, C, D, E. Join these points OA, OB, OC, OD and OE. So, if you observe this, length of every line is a 5 centimeter. In fact, OA, OB, OC, OD, OE are radii of the circle. So, the length of each line segment OA, OB, OC, OD and OE is 5 centimeter, which is equal to the radius. Mark some other points on the circle and measure their distances from the point O. So, if you mark any other points like this and measure their distance, so what can you observe? What have you observed, students? So, we can say that a circle is a collection of all the points in a plane which are at a fixed distance from a fixed point on the plane, and the fixed point O is called the center of the circle and the fixed distance OA is called the radius of the circle. So, what we can say, students? A circle is a collection of all the points in a plane which are at a fixed distance from a fixed point in a plane. The fixed point O is called the center of the circle and the fixed distance is called the radius of the circle. Next, let us see. This is a circular park and one student is walking around the circle. So, in a circular park, 𝗧𝗦 is a student who is started walking from a point around the park and completed one round. So, he started from here and he completed one round. Then, what do you call the distance covered by 𝗧𝗦? So, he started from here and he rotated and he came finally, he started from here and he made a one rotation and reached here. What do you call the distance covered by 𝗧𝗦? It is the total length of the boundary of the circular park and is called circumference of the park. So, the complete length of a circle is called the circumference of the park. So, the border is the length of the circle is always called as a circumference of the circle. Now, do the following activity. Mark a point on a sheet of paper. You take a paper and mark a point on sheet of paper taking this point as a center with any radius and draw a circle. So, with that point as a center, with your own radius you draw a circle. Now, increase or decrease the radius and again draw some more circle with same center. One point we mark here, and with taking some radius we have drawn a circle. Now, increasing the radius and drawn one more circle, and now decreasing the radius and drawing one circle from the same point, and from the same point by increasing radius one more circle and increasing the radius one more circle. So, we have drawn 5 circles with the same radius but different, we have drawn the 5 circles with same center but different radius. So, what do we call these circles? What do you call the circles obtained in this activity? So, we have drawn 5 circles with different radius and same center. So, these circles are all called concentric circles. Circles having a common center are called concentric circle. That means, if 2 or more circles having same center with different radii are called concentric circles. Now, let us see congruent circle. What are the congruent circles? The congruent circles are these 2 circles we are having with the same, with a different center but same radius. So, circles having same radii but different center is called congruent circles. And what happens if same center and same radius? The circle with same center and same radii are called as congruent circles. The circles with same center and same radius are called as coincident circles. So, we have seen congruent circles, concentric circles and coincident circles. So, congruent circles is nothing but having same center but different circles are called concentric circle. And second one, same different center but same radius is called congruent circle, and same center and same radius are called as coincident circles. Now, let us see circle and plane. So, this is a circle and this is a plane. So, this circle divides plane into 3 different parts, and one part which is the inner side, and one is the outside part, and one is the part which is on the circle. The first part is a circle always divides the plane into 3 parts, inside or interior of the circle. So, this total part will be inside or interior of the circle. And second one, on the circle, or we can say or circumference. And the third one is outside or exterior of the circle. So, if I take a point A which is inside the circle, B this is also inside the circle, and if I take C and D both are on the circle, and E and F are the points exterior of the circle. Now, chord and diameter. What is a chord? Chord is nothing but the line joining 2 points of the circle is called the chord. Chord is nothing but the line segment joining any 2 points of the circle is called the chord of a circle. How many chords we can draw to a circle? We can draw infinite many chords to a circle. So, this is a 2 points P and Q. Here PQ is a chord. So, what is the longest chord? The diameter of a circle is the longest chord of a circle. So, if I increases size of the chord, it will passes through the center of the circle. So, which we can also call it as chord, which we can also call it as diameter. So, the diameter of the circle is the longest chord of a circle, and we all know that always diameter is equal to 2 times of radius, or else we can say half of the diameter is called as radius. So, diameter, what is the diameter? The chord passing through the center of the circle is called the diameter, and we can say the midpoint of the diameter is always a center. The midpoint of a diameter is always a center. Now, let us see what is the arc and segment of a circle. So, this is a circle, A is a point on the circle, B is a point on the circle. So, AB is a part of a circle. So, AB is a part of a circle which we call it as a arc of the circle. We can say this is a and B. In this figure, 2 points A comma B are on the circle, and they are dividing the circumference of the circle into 2 parts. So, one AB is a one part and downside is one more part. So, we can say the part of the circle between any two points on it is called an arc. What is arc? The part of the circle between any two points on it is called an arc. Here AB is called an arc and it is denoted by AB. This is the symbol for arc. So, AB is called an arc and it is denoted by AB with an arc symbol. Now, let us see, this is a circle and AB is a diameter. AB is a diameter and A and B are end points of the diameter and C is a point. If the end points of an arc become the end points of a diameter, then such an arc is called a semicircular arc. So, what is a semicircular arc? If the end points of an arc become the end points of a diameter, then such an arc is called a semicircular arc. So, here ACB is a semicircular arc. If I take a point here as D, ADB will be also a semicircular arc. So, a circle divides into two equal semicircular arcs. Now, O is a circle and A is a point on the circle and B is a one more point on the circle, then AB will be minor arc. AB will be minor arc. If the arc is smaller than a semicircle, then the arc is called a minor arc. So, here if the arc is longer than a semicircle, then the arc is called a major arc. So, depending on the arc size, if the arc is smaller than a semicircle, then the arc is called a minor arc. If the arc is longer than the semicircle, then the arc is called the major arc. So, now we have seen three types of arc. One is a semicircular arc, minor arc and major arc. So, that depends on the size of the arc. If the arc is smaller than a semicircle, then the arc is called minor arc. If the arc is longer than the semicircle, then the arc is called major arc. So, in this figure, AB is a minor arc and if I mark a point C here, ACB will be minor arc and if a point D is here, ADB is a major arc. So, in this circle, ACB is a minor arc and ADB is a major arc. Now, O is the center of the circle and AB is a chord. Now, let us see what is the segment of the circle. AB is a chord of the circle, then this chord divides circle into two equal segments. AB is a chord which divides circle into two parts. One is a minor segment. What is a minor segment? If we join the endpoints of an arc by a chord, the chord divides the circle into two parts. One will be minor and one will be major. This is a major segment and this is a minor segment. How we define the one is a major segment and one is a minor segment? That depends on the size of the arc. If it is a minor arc, the segment will be minor segment. If it is a major arc, then the segment will be major segment. Now, this total will be minor segment. What I can say, the region between the chord and the minor arc is called the minor segment and the region between the chord and the major arc is called the major segment. So, what happens if the chord is a diameter? If the chord is a diameter, then the diameter divides the circle into two semicircular segments. That means a chord divides circle into two parts. If the minor arc is there, then the segment is called minor segment. If the arc is a if the arc is a major arc, then the segment is a major segment. If the chord is a diameter, then the diameter divides the circle into two semicircular segment. So, we are having three types of segment. One is a minor segment, major segment and semicircular segment. So, minor segment means the area enclosed between chord and minor arc, and major segment is nothing but the area enclosed between chord and major arc, and semicircular segment is nothing but two equal segments. Okay. Next, what is a sector? Sector is nothing but this is a circle and OA and OB are two radius and this is a major sector and this is a minor sector. So, the area enclosed between two radii and one arc is called a sector. Sector is nothing but the area or the region enclosed between two radii and an arc is called a sector, and OA is a radii and OB is also radii here. These two are radii, one is a minor segment and one is a major segment. The area enclosed by an arc and the two radii is called a sector. If the arc is minor arc, then the sector is called minor sector. If the arc is a major arc, then the sector is called the major sector. So, always we can say the area enclosed by an arc and two radii is called a sector. If the arc is minor arc, we can say the sector is minor sector. If the arc is major arc, then the sector is called major sector. Now, let us see angle subtended by a chord at a point on the circle. Angle subtended by a chord at a point on the circle. So, in this case, we are having three cases. First one is angle at a center of the circle, angle at a point on minor arc, angle at a point on major arc. So, first one is angle at center of the circle, and second one is angle at a point on minor arc, and third one is angle at a point on major arc. Now, let us see each and every case, and the first case is angle subtended by a chord at the center of the circle. So, this is the circle and two radii OA and OB are radii, and AB is a chord here. AB is a chord. Now, AOB is an angle made at center. AOB is an angle made at center, and AB is a chord here. OA and OB are radii. Now, let A comma B any 2 points on a circle with center O, join AO and BO. Angle is made at center O by AO and BO. Then the AOB, angle AOB, this is the angle which is called as a angle subtended by the chord AB at the center O. Now, angle subtended by a chord at the point on the major arc. Now, see, this is the circle, PQ is a chord, PQ is a chord, and R is a point on the major arc. So, PQ is a chord here and R is a point on the major arc. Now, PRQ is an angle, PRQ is an angle, right? Now, PQ is a chord, R is a point on major arc. The PRQ is called the angle subtended by the chord PQ at the point on the major arc. So, here PQ is a chord and R is a point on the major arc, then the angle made by PRQ, the PRQ angle is called the angle subtended by the chord at the point on the major arc. Now, angle subtended by a chord at the point on the minor arc. Now, this is a minor arc, PQ is a chord, the same chord, and PQ is a minor arc, S is a point on the minor arc. Now, PSQ will be the angle. Now, let us see, PQ is a chord, S is a point on minor arc, then PSQ is called the angle subtended by the chord PQ at the point on the minor arc. Now, angle subtended by a chord at a point, let us see all together once. Now, PQ is a chord and this is the angle on the minor arc, and this is the angle on the major arc, and this is the angle at the center. Now, PQ is a chord, POQ is called the angle subtended by the chord AB at the center O, and this is the angle POQ, this is the PRQ, angle subtended by the chord PQ at the point on the major arc, and third one is angle PSQ is called the angle subtended by the chord PQ at the point on the minor arc. So, depending on the point, whether it is on the major arc, whether it is on the minor arc, whether it is a center. So, based on that we can say that is the angle subtended by the chord at center, or else we can say the angle subtended by the chord PQ at the point on the major arc, or we can say the angle subtended by the chord at the point on the minor arc. Now, observe student this one, circle, PQ is a chord and RS is also a chord. So, in the figure O is the center of the circle, PQ and RS are the chords of the circle. So, we can observe PQ and RS. What is the relationship between PQ and RS? PQ is greater than RS. The length of the PQ is greater than length of the RQ. Then what happens? Angles angles also will have same relation, that is angle POQ is greater than angle ROS. So, what we can say is the angle subtended by the chords at the center of the circle increases with increase in the length of the chord. That means, if the length of the chord increases, the angle also increases. If the length of the chord decreases, the angle also decreases, right. So, what will happen to the length of angle if two chords are equal? So, here what we have observed, the angle subtended by the chords at the center of the circle with the increase in the length of the chord. If the length of the chord increasing, angle is also increasing. If the length of the chord decreasing, the angle also decreasing. Now, students, what happens if the length of the chord is equal? What will happen to angle if two chords are equal? So, if two chords are equal, what is the relationship between their angle made at the center? Now, what we can say is the equal chords of a circle subtended equal angles at the center. That means, if the length of the chords are equal, the angle also equal. So, this is a circle. Let us prove this theorem. Circle with center O, AB is a chord and CD is also chord, and both the chords are in equal length. So, equal chords of a circle subtend equal angles at the center. Now, let us prove this theorem. What is given? Let O be the center of the circle, AB, CD are equal chords. AB, CD are equal chords. Angle AOB, COD are the angles subtended by the chords at the center. This is the AOB. AOB is called angle subtended by chord AB at center, and COD is the angle subtended by the chord CD at the center. Now, what we need to prove? We need to prove angle AOB is equal to COD. These two angles are equal. We need to show that. So, what is the theorem? Equal chords of a circle subtends equal angles at the center. We have to prove angle AOB is equal to COD. So, for proving in triangle AOB and triangle COD, AB is equal to CD. AB and CD both are equal. This is a given because equal length chords we have taken. So, AB is equal to CD, both the equal chords, and OA is equal to OC. This is the OA and this is the OC, because both OA and OC are radii of the same circle. So, always radii of the same circle is equal. OB is equal to OD. So, radii, this is also radii of the same circle. So, AB is equal to CD, OA is equal to OC, OB is equal to OD. That means three sides are equal, corresponding sides are equal. We can say by SSS rule, side rule, triangle AOB is a congruent to triangle COD. So, what we find here, triangle AOB is congruent to triangle COD. So, therefore, angle AOB is equal to COD. If these two triangles are congruent triangle, we can say by corresponding parts of the congruent triangles, the angles are equal. Corresponding parts of the congruent triangles, we can say angle AOB is equal to COD. So, what we can conclude? Equal chords of a circle subtends equal angles at the center. So, this is the proof of a theorem. How we have proved? There is a two chords AB and CD and two radii OA, OB for AOB triangle and OC and OD for OCD triangle. So, we have proved first OAB and OCD two triangles are congruent. Then from that we have finalized that angle AOB is a congruent to angle COD. So, therefore, equal chords of a circle subtends equal angles at the center. Now, converse theorem. So, what is the converse theorem? If the angle subtended by the chords of a circle at the center are equal, then the chords are equal. So, if the angle subtended by the chords of a circle at the center are equal, then the chords are equal. So, what we can finalize? If the chords are equal, if the angle made at the center is equal, then the chords are equal. What we have learned, students? We have learned the definition of circle and the related terms. We have learned what is a center, what is a radius, what is a chord, diameter, and also we have learned arcs and segments of a circle. So, what is a arc, what is a minor arc, what is a major arc, what is a semicircular arc, and also what is a major segment, what is a minor segment, and what is a semicircular segment we have learned. And also we have learned angles subtended by a chord. If angle subtended by a chord at center, or angle subtended by a chord on major arc, and also we have learned angle subtended by a chord on a minor arc. So, students, in the next session we will continue the circles topics. Okay, thank you students.